You've probably seen this before, but have you seen this? Okay, what's going on? There is no trick actually. Two people sitting across from each other can look at it at the same time and see completely different things. And that's just a fundamental property of the component that's at the heart of this build. This is usually called a beam splitter cube. Light entering from one face hits a 40-degree plane inside the glass. Some of it passes through, but some gets reflected at 90 degrees. So if you put a screen on one of the sides and look in from another, you see it. This basically uses half of the cube, so we can do the same with the other half. Both images exist simultaneously, no electronics trickery required. It's just optics. There's some interference from light bouncing inside the glass, but that's manageable. This is episode 2 of my Space Cadet build series, where I show standalone projects that will eventually come together as a puzzle box game. The idea is that two players sitting across from each other see instructions meant for the other person. So you have to communicate and cooperate. As a bonus, they get to see each other's faces through the glass while trying to talk over each other. But regardless of my use case, I would love to see what you good people out there may come up with and use this effect for get liking and subscribing. Actually build something with this and let me see it. That would be so much more rewarding for me. The screens are monochrome OLEDs, slightly larger than the cube face. I initially wanted to use that creatively and expose the extra bits as decorative light bars around the cube. It turned out impractical, so the enclosure cropped them down to just the active area. Screens are great, but I ran into a strange viewing angle problem. OLEDs normally have excellent viewing angles, so it took me a minute to figure out. Testing with plain LEDs showed no issue, so that pointed immediately to one culprit: polarization. The OLED panel has a polarizing filter, and I guess the cube also has one. No idea what's going on further. But I've seen Sabine Hossenfelder baffled by polarization tricks, so I'll simply accept this knowledge gap for now. Especially since simply turning the screen 90 degrees completely fixes everything. I was already starting to look for alternative screens, but I'm back on track. From this point, there was a lot of iteration in CAD and a lot of prototype print. The enclosure is two side panels, one per screen, that sandwich the cube between them. They mount into a base that houses the microcontroller. Filament choice was easy this time, especially for the faces, black to minimize reflections. Honestly, I prefer when function makes the color decision for me. This episode is sponsored by PCBWay. I want to make a genuine case for why they are more than just a PCB manufacturer. The breadth of their services means that I can put a 3D print, a CNC part, and the PCB on the same order. One checkout, one delivery, that means a single shipping cost. If you watched episode 1, you already saw what their electroplating finish looks like on the spaceship. For this episode, my FDM printer was sufficient for this prototype, but I can't wait to get rid of all those wires with a custom PCB in the final puzzle box. Go check them out at pcbway.com, the link is in the description. Speaking of wires, the screens interface over I2C, each one with a different address, and I used the Wemos D1 Mini for this one just because it's my favorite microcontroller and it's a small one. You might notice some more components here, they are unused for now. Jamming everything in the box, no battery this time, I'm just routing a USB cable out. There's a bill of materials or shopping list in the description or the pinned comment, including the cube.